Hey, Gleb Alexandrov here for CreativeShrimp.com. Welcome to yet another tutorial from the hard surface modeling update for Blender 2.80 and above. In this video, we'll talk about the real-time viewport rendering features of Blender 2.80, namely the Workbench engine and how it can be useful for the hard surface modeling. Then we'll explore Eevee and its bells and whistles. So that's pretty much our plan. To cut the story short, the new render engines and the new viewport features like outlines, madcaps, edge detection, flat lighting, random object colors, colorful wireframes, all of it makes 3D modeling much more informative, but also much more fun, because it's a pure delight to work with these new render engines. First of all, let's sort out the potentially confusing moments related to user interface that can bog us down. There are lots of new things in 2.80 and above. First of all, we have a bunch of new render engines. In this render panel, you can switch over to one of them. Right now it's set to Eevee. And the solid shading of Eevee is pretty much the Workbench render engine. It makes it a little bit confusing, but it's the same as enabling Workbench. So the solid shading mode of Eevee is actually Workbench. Another thing to keep in mind is that the settings of the Workbench can be changed in the top panel over here. But if you switch over to the rendered mode, you'll have pretty much the same set of settings, but in the render settings panel instead. But other than different locations in the user interface, these are the same settings practically. Now let's get into the lighting settings of Workbench and see what we can do. Right now we're on the studio lighting. We can change the different presets over here or click on the cog icon and customize our own studio lights by pressing Edit Studio Light. Additionally, we can install the custom presets by clicking the Install button. Changing the lighting presets means getting a fresh look at your model. And it's totally worth it to change the lighting presets once in a while. Our perception of form largely depends on how light rays bounce off the object, so we should never underestimate the importance of lighting, be it like final rendering or the 3D viewport for that matter. Say a seemingly inconsequential tweak like changing the light source position, or rather direction, can change the way you approach this particular model for some reason. Maybe it looked fairly well under certain lighting conditions and then you changed it, and out of a sudden you discover that the proportions are totally off. That is definitely something that happens to me all the time. To the right of the studio, we have the Madcap. Madcap stands for material capture. Essentially, it has both lighting and material properties baked in, and it depends on the viewing angle. In ZBrush and other software, it gives very high performance and informative feedback for sculpting and modeling. We have a pretty large selection of madcaps in Blender, each giving a slightly different feel to 3D modeling. We have a classic ZBrush style walks, if you're into this look, and actually a lot of different looks. Some of them great for debugging, for example more glossy ones like this metal. As a rule of thumb, these madcaps that simulate slightly reflective materials are great for revealing all kinds of shading artifacts, like the pinching effect that you see over here. The diffuse madcaps, on the other hand, are not so great for revealing that kind of truth about your mesh. So yeah, the reflective madcaps are great for debugging the curvature and smoothness issues of your mesh. So then you can go over these things and dissolve some edges and so on. And if the default selection of madcaps doesn't cut it for you, you can find more on the internet. Search for call for content madcaps. This is the thread on the official Blender site with lots of great madcaps that you can download and install in Blender. Thankfully, at last, we can do it now. We can install new things in Blender 2.80 and above. So, for example, here I downloaded the planet.exr file. Oh, by the way, we can change the direction of the madcap. So, yeah, to install the new one, I'm clicking on the cog icon. Then I'm going madcaps, install. I'm navigating to the folder in which I saved the file. And I'm pressing install custom studio light. After doing that, we should be good to go. Here is our planet Madcap. Let's save the user preferences just in case. I know that they should be saved automatically, but it's better to be safe than sorry. Now we should see this newly imported Madcap in the collection, and we can choose it. Whoa, actually that looks sci-fi-ish, I love it. Very spacey. So these were Madcaps. I think they're awesome for visualizing our models. Moving on from there, we have the flat lighting, which is slightly reminiscent of how technical drawings look. Actually, flat lighting means no lighting whatsoever, no interaction between light rays and material surface. You just have flat areas of color, two-dimensional shapes and outlines instead of three-dimensional forms. This mode is great for getting a clean read on the silhouette and also on the distribution of details. Very useful mode, I love it. But let's jump back to the studio mode and have a look at the color options we have here. As you can notice, the eyes of the robot are blue because we have blue color set up in the material. But if we switch to the single color, we can define the single color for the entirety of our models in the scene. Alternatively, it can be set up on the per object basis. If we switch over to the object mode, that means that somewhere within the object data tab, we have the color. We can change it on the per object basis, as simple as that. One of the ways of how we can assign it to multiple objects at once is right click on the color and copy to select it, while making sure that the active object is actually the one with the color that we want to propagate to all other selected objects. Alright, with that being said, I usually just stick to the material color, but that doesn't mean we cannot explore all other options. There are some exciting things among them. For example, what we can do is go over to the vertex paint mode. And where is our toolbar? View tool settings, alright. So think about it, we can paint the object with a certain color and this color will be displayed. What a feature. Groundbreaking stuff over here. Well, good to know, good to know. More options are better than less options. Though, I guess there are cases then less is more. So it's controversial. But not controversial enough to spark a conversation, I guess. We also have the texture mode, which I won't be showcasing because we have no textures. And the other one is super interesting, the random mode. As a little bit of off topic, I couldn't help but notice that a random pool of colors that Blender uses for that thing looks actually pretty cool. So it's not entirely random. There is definitely some artistic vision behind it. Alrighty then. We also can change the wireframe color, which is, I think, enormously useful to discern between different objects, especially if your mesh is very complex. It can be single color, it can be based on the object color, which can be found in the object data tab, or once again, it can be random. Randomly colored wireframes is something that was requested for years. And now we have it, just like 3ds Max. But actually, this is a pretty useful feature. Imagine that you have thousands of objects in your scene, and you need a reliable way to tell them apart from each other. What belongs to which group or which mesh. And here the random colors enters the chat. And you can tell instantly that this leg, in fact, is a singular mesh. That tells you that you probably merged it at some point, and you don't even have to go into the edit mode to be able to tell that. And it's very cool. Now, why don't we talk about the background options that we have in Blender 2.80 and above? We can switch between the theme colors, the world, and the viewport color as well. It may seem a little bit superfluous. Why have so many different options in many different areas of Blender? But if you think about it, it's how Blender works. It just gives you choice. Multiple choices, actually. So yeah. Usually I end up shifting the viewport color a little bit towards blue for no particular reason. That's what we used for recording these tutorials. That was written in our style guide, actually. We have a style guide with all the fonts and colors for our tutorials. Imagine that. And speaking about images, let's talk about where to put the background image in 2.80. this is something that changed in between versions, so I think we should catch up with the changes. First of all, it can be found underneath the image, reference, or image background. These two options are pretty much the same. And here right away you can see this new right menu that you can toggle by pressing N. But actually what I want to do is head over to this menu and click on thumbnails to see what we have to pick. And I will pick this biped. What can be better? Import. So after choosing some image, it gets imported straight into Blender. We can change its rotation, position, scale in the right hand menu that can be brought up by pressing N, or just how you do it usually with the gizmo or with the hotkeys. And all these settings can be found underneath the image panel. Here we can define which objects will occlude the image. Will it stay always on top of the other things in the viewport? And also, do we want only the front side of the image to be visible, or front and back sides? That's practically the same as the back face culling. Okay, what else can we do? We can make it show only in the orthographic views, the top projection, front, back, side, or in the perspective views as well. And to quickly show how the depth setting works, which is basically the Z depth setting, let's add a plane and make it intersect with the background image. And what if we want the background image to always stay on top? We just choose back in this case, or maybe front if it's turned the other way around. So you get the point. This may come in handy if you want to model using a reference, like for example we did for the hard surface modeling video course in modeling our robo. I should have said in blocking out the robot. Well, not exactly this robot that you see on screen, some other robot, but yeah, we imported the image plane, and then we outlined and copied the main shapes and then extruded this whole thing and proceeded from there. This is a cool workflow indeed. And yet another way of adding background images to Blender is the import images as planes add-on. It was in Blender since the beginning of time, I think. We can find it in the user preferences underneath the add-ons panel. Okay, so once we enable the add-on, we can go Shift-A, Image, and select Images as Planes, and then navigate to the folder with the images. I will select this beautiful robotic head, double-click, and oh, we see the error. It relates to the Workbench engine, because Images as Planes works only in Eevee and Cycles, so let's switch over to Eevee. I think it looks wrong. We messed something up. Let's see what we can do. Maybe we can delete it and Shift-A, Images as Planes to add that again. And let's see. Probably we have to disable Use Alpha. And also I would switch the material over to Shadeless. Now re-import the image and yeah, it did the trick. Well done. Okay, so I guess that's it for adding the background images in Blender 2.80. Oh, actually no. There is one more way of adding background images to Blender. That is, if we were to view our world through the camera lens, we can go over to the camera settings, check the background images, and add our image over there. This way, it will become visible only through that particular camera, and only when you switch to the camera view. And in addition to that, to change any settings, you will need to come over to the camera panel and change it from here, like making it more transparent. Now we have a few more features to explore, so let's jump back into the viewport shading menu at the top of the screen. We have backface culling, cavity, depth of field, and so on. Let's start with the backface culling. Now look, that's a kind of a wizardry. That checkbox makes backfaces disappear. On the bright side, that's good in terms of performance. That's why game engines use it by default, all around the place. So we see the plane, and we see it no more. It's gone, and I can prove it. So that's the backface culling, as simple as it goes. And what other options do we have here? we have the X-ray checkbox, which makes everything semi-transparent. And you can tweak the transparency by tweaking the slider. And right next to it we have the shadow, but let's change the scenery. Yeah, that's a ton better. Jumping back into the viewport shading options, we have a few more things here. The outline, for example. The outline checkbox draws the outlines in screen space, unsurprisingly, and it's never to be underestimated. Small features like that give us additional depth cues, which helps the depth perception. Once activated, the outlines help us to separate these three cylinders visually. Well, without the additional cues, it's still possible to tell the depth of the scene, but why not help our visual system by giving those additional cues, like shadows, for example? Shadow is yet another useful visual indicator by which we can judge distance between the objects, whether one object is sitting on top of the other, or maybe it's floating. How could we tell? By shadows, alongside other information present in the scene, like cavity. Well, we'll talk about that in a minute. The direction of the light source can be changed, of course, just like any other thing. And look at this, we're able to tell that the cylinders are floating just by looking at the shadow that it casts. And once we bring it closer to the floor, the gap between the object and the shadow is bridging. I know that's obvious, but it works on an intuitive level. We grasp things like this really easily. We have absolutely wonderful, very well trained visual system that just grasps the cues like that. The next amazing feature of the Blender viewport, very useful for modeling, is cavity. In order to show that, I'm gonna disable shadows and outlines. Let's now pop in the cavity, and to me it feels like the ambient occlusion effect. Good old ambient occlusion coupled with the edge detection or edge brightening. It operates in the screen space as well as the world space, and basically it outlines or brightens the edges and darkens the areas where objects are close to other objects. We have the ridges and valleys slider where we can tweak the strength of the effect, and in the type dropdown we can choose between screen or world or both. Each of these methods has its own pros and cons. They work slightly differently. The world space shader operates on the actual vertices, while the screen space shader operates on pixels, and it can cause kind of a weird brightening of the wireframe. So I guess it's a matter of finding the right balance between how pronounced do you want this effect to be and what kind of rendering artifacts you can tolerate. In my opinion, just like shadows and outlines, this is amazing how this effect helps us to understand the space we are working in, how close the objects are to one another, where does the meshes actually reside in space, and how do they relate to each other in terms of distance and size. I'm usually pretty careful about overdriving this effect. I try to keep it pretty subtle, just like other effects. And also you can set the number of samples. This may cause a performance drop, especially if you have many objects in your scene. But so far I didn't notice large performance hit, so it's pretty safe to set it to 32 samples, something like that. Let me show how it works really quickly by arranging a famous cylindrical test. So here we have two cylinders. Let's disable the cavity for a moment, zoom in. Yeah, and unsurprisingly, there is practically no visual separation between those two models. But once we enable the cavity checkbox, we get this sense of space and separation back. It works much better if you ask me, especially if we also set the type to both and carefully adjust the ridges and valleys for every slider. But once again, I approach it very carefully. I chicken out to not accidentally create the dirt shader. That would be unfortunate. What we really need is clarity, and that's all. So from that standpoint, it's very handy that we have a whole set of settings that we can adjust to fit our modeling expectations. And I think we forgot to mention the specular lighting. It does exactly what it says on the tin. enables specular highlights, and we can control it from the Viewport display menu within the Materials tab. Two settings there, metallic and roughness, that mimic the settings of the PBR materials in Blender. So this sums up the Viewport shading in Blender. Plenty of different options, but the whole point is to adjust the parameters of the Workbench engine to help ourselves with 3D modeling. It all boils down to arranging a comfortable workspace where you can read 3D shapes instantaneously without spending any extra mental energy on it, so you can actually concentrate on things that matter, on stretching vertices and pushing polygons. And to give this whole Viewport thing extra nudge over the cliff, we can opt in for Madcaps, in addition to shadows, cavity, ambient occlusion, and edge detection, for the ultimate Viewport experience. With that being said, we can conclude this tutorial from the hard surface modeling update for Blender 2.80 and above. My name is Gleb Alexandrov, and I'll see you in the next tutorial.